Hey everyone, and welcome to the AWS Nordics Office Hours with me, Gunnar Grosch, developer advocate here at AWS. And this is my weekly show where I bring on AWS experts to talk about specific topics and let you, our viewers, ask any questions you might have on that topic or basically any AWS topic, and we'll do our best to answer those. So if you have any questions, any comments, just pop them in the chat and we'll do our best to answer those. And this week, I'm joined by Thiru, Solutions Architect here at AWS. So welcome to the show.
Hey, good to be here. How's it going?
Great to have you. Yeah, well, it's going great. So tell people a bit about yourself.
Sure, thanks. So my name is Thiru, as I said. I am a solutions architect in the Danish team. So something interesting, or at least for me, is the fact that I just moved to Denmark about a month ago. Which is also one of the reasons why you see a completely empty room in the back. It's as clean a studio as it gets. It's a new house, so still fresh off the boat, if you will.
I would say that you've definitely embraced the Nordic Scandinavian style of decorating. It's just a white room, nothing else, and just a wooden floor.
It's minimalist. It's as minimalist as it gets. Yeah, absolutely.
Exactly. Well, great to have you with us. And once again, hi, everyone watching. Thanks for joining us. And as I mentioned, we have a specific topic each week. And this week is super exciting. We're going to talk about how to get started using Kubernetes on AWS. And to get there, I think we need to talk about containers to begin with, because there are some options when we want to run containers on AWS, right?
So containers, maybe it's good if we start talking about containers first and then go on to Kubernetes, because without a good understanding of containers, more advanced topics like Kubernetes or maybe even continuous deployment, those sorts of things may not necessarily make sense. So typically, when you work on applications, you have when you want to deploy an application, you need the application code, you need the application's dependencies, and then you need any other configuration items, things like environment variables, mount points, or stuff or a location where the application can store state, for example. And typically what happens is when you run it on a server, let's say like a virtual machine, you would need to download the code from somewhere. You need to prepare the server to be able to run that code. For example, if it's Node, then you would need to install Node. You need to ensure that the version of Node that you're using is the correct version, and you need to install the dependencies. And as a lot of us know, and probably have torn our hair out, NPM is just fantastic to work with. So you need to manage all of those dependencies, and then you also need to manage things like mount points and so on. So this works really well, or at least it tries to work, when we are looking at a single machine, single server. What happens when we need to deploy our applications at scale? You need to repeat this process. So thankfully, AWS, we do have solutions for that. Some of you might have come across the AMI, which is essentially like a golden image for a virtual machine, in this case, EC2 to use. But again, that comes with its own set of problems, because virtual machines take some time to start up. So even though you can scale VMs, they do take time to start up. And in some cases, you need capacity to be added very quickly. One of the ways we try to mitigate this is by using something called a container. So a container is sort of like an application package, a portable package of code, of the runtime, of the dependencies, and also any other configuration items packaged into essentially like a little food container. And you can run this container in any sort of platform, whether you want to run it on an EC2 instance, you want to run it on a serverless platform, you want to run it on a Raspberry Pi, you can run it anywhere as long as you have something called container runtime. And one of the most popular container runtimes, and unfortunately reducing in popularity these days, is something called Docker. Most of you would have heard of something called Docker, and essentially Docker can be installed on a wide variety of platforms, and all you need to do is just do a simple command, run a simple command, and Docker will sort of like pull the image from something called a container registry and run it, and you are able to pass network traffic to it so that the application can start to serve, essentially do what it's meant to do, right? So that's again one container. Now, what happens when we want to scale to many containers and many different applications? You might have heard of the Microservices Paradigm, which again is also very popular these days, versus monolithic architecture. Let's not get into that discussion because that's we'll never finish. But suffice to say that microservices, you can have multiple microservices and they all need to talk to each other using some sort of well-defined contract, typically like a REST API or some sort of API in the backend. And when you get to a certain scale, managing all of these containers tends to get difficult, which is why you need something called a container orchestrator or a container scheduler. And the most popular of these is Kubernetes. And if you haven't been under a rock, you probably would have heard about Kubernetes. Everyone and anyone is basically talking about Kubernetes and trying to use it. Whether or not Kubernetes solves your issues is obviously not a discussion for today. But let's say Kubernetes was able to solve your problems, right? And let's say you're an organization who develops mobile applications and you want a very robust and scalable backend. Or let's say you are an e-commerce store, a web store, and you want to expand to more locations and you want scalability and you want more agility in terms of creating and deploying new features, which is another thing that I didn't talk about containers. And that is the fact that because it's so easy to package and to deploy, you can create new application code in a very quick amount of time. You can even create new features on a daily basis if you've got the bandwidth, if your team is large enough, or if you've got the time, you can deploy new features on a daily basis because all you need to do is to change the code, package and build a new container, and submit it to the container orchestrator Kubernetes, and it will basically run the new container for you. And it's all super easy to do. So maybe if we can go on to like a demo of some sort, I can talk a little bit more about that.
Yeah, for sure.
Let me maybe show. Sorry, yeah.
Yeah, so just to summarize a bit, running containers means that it makes it easier for you to then package those applications, the code that you build, and the dependencies you mentioned, NPM, have them packaged together and can then run them in a repeatable way, so you can scale your application more repeatedly. And compared to a virtual machine or an instance, you don't have to think about the underlying operating system. So you don't have to worry about the updates of the operating system or maintaining that operating system within your container.
Yep, absolutely. And to add on a little bit to that, there is this very clear separation of responsibility as well, because as a developer, you don't really need to worry about what your application is going to run on. So for all you know, as I said, it could run on a Raspberry Pi, but you don't need to know that, because all you need to be concerned about is your application, your code, and your dependencies. And if you have a well-defined access mechanism, a well-defined contract with which to access your service, then you can essentially deploy your service anyway. But that's more of a process issue rather than a technical issue.
Yeah, but and I suppose the same goes for the development process. So it makes it easier for developers to test out those containers in basically on different platforms or your own computer without having a large cluster running to be able to test it out on.
Sure. And you bring up a really good point. We don't need to worry about how it ran on my computer, so I'm not sure why it's not running in production. You'd be surprised at how much we still face those issues from customers. We still hear about those issues from customers. You might think, oh, containers have been around for a while. Maybe even Kubernetes has been around for a while. I first used Kubernetes way back in 2017. And we still hear customers having challenges with application deployment with, it ran on my machine. I'm not sure why it's not running in production. So all of these are problems that are solvable, and hopefully something like Kubernetes and containers will be able to solve them.
So let me ask you the $1 million question then. Is it complicated to run Kubernetes? Does it have to be complicated?
You started off heavy.
Yeah.
It really depends. Kubernetes does, unfortunately, or depending on how you see it, Kubernetes can be as difficult or as easy as you would like. I personally find that there are a lot of add-ons and applications built on top of Kubernetes that add a lot of complexity, but at the center of it, it is relatively easy to get an application up and running on Kubernetes. In fact, from the end-to-end process of packaging your code, building a container, pushing it into Kubernetes, it is fairly straightforward. It is only when you want to do things like global scale, millions of containers, hundreds of services, that's when complexity gets added on. But then even when you are looking at virtual machines, even when you're looking at conventional infrastructure, it does tend to get a little complex. The way I see it is you can see complexity in both sort of environments.
Right. And maybe what you're showing on screen right now can be of great help there as well. So tell us about what you're going to show us today.
Yeah, so this is the main documentation page, product page for EKS, which is AWS's managed Kubernetes service. So Kubernetes can be run, as I said, anywhere. In fact, if you want to run Kubernetes on a Raspberry Pi, that's possible too. If you want to run Kubernetes on your own bare metal infrastructure, doable. But there is a certain process that you need to go through to provision the cluster, to register the nodes where your containers are going to run. You need to manage the networks. You need to manage a lot of the underlying infrastructure for Kubernetes before you can actually start using Kubernetes, which is where a managed Kubernetes service actually really helps, because it makes your day zero process, if you will, of provisioning the actual cluster a lot easier, and you can start focusing on deploying the containers rather than deploying Kubernetes itself. So EKS, Elastic Kubernetes Service, is our managed Kubernetes service. And what we do is we provide you with a managed, what we call a control plane. So the control plane is sort of like the brain of the cluster. So it contains a few core components, like the API server, a key value store called etcd, etcd, which actually maintains the state of the entire cluster and all of the applications that run with it, and also a mechanism that allows Kubernetes to schedule containers in each of those worker nodes. So we call them worker nodes because they are instances or servers that are attached to the main cluster, and the cluster will be able to understand which of these other instances have the compute capacity to run these containers on them. Yeah, that's basically going into the sort of like the gnarly bits of Kubernetes. But suffice to say, it is a very robust, very capable distributed system.
And this is still running the regular Kubernetes that anyone can download and run. It's just that it's on a managed platform, so we take care of the underlying infrastructure of it.
Yes, yes. And EKS is just a little bit behind what we call upstream Kubernetes. So something that's important to note is Kubernetes is fully open source. In fact, Kubernetes was sort of like the first project in the CNCF. So if you've heard of something called the CNCF, it is the Cloud Native Computing Foundation. And I'm also wearing a Kubernetes shirt for branding. It's fully open source. It's managed by the CNCF Foundation, and any new versions of Kubernetes, the latest one that we have here is 1.23. There should be, and I'm not 100% sure about this, there should already be a 1.25. So AWS EKS, Amazon EKS is a few versions behind. And the reason why we have it a couple of versions behind is for compatibility reasons. We don't want customers to always need to be on the latest version, because it also takes away time from managing their own infrastructure, from managing their environment in that sense. So if we keep on updating it and we make customers update to the very newest version, then it kind of takes away the benefits of a managed service.
All right, so we're 18 minutes into the show. This is the AWS Nordics Office Hours. It's time to show something, Thiru. So
yes, absolutely.
Let's see what you've got for us. We want to get started with Kubernetes on AWS. That's basically the title of the show.
Yeah, of course. So let us get started. I suppose we can talk all day. But what I did want to show is what I'm going to try and deploy today. So what I've done is I've created an application that is got essentially a single front end with two backend components, which are two microservices. This is backend 1, and then this is backend number 2, which each connect to an RDS database. Sorry about my handwriting. And DynamoDB database in the back.
I think you deploy the RDS outside of screen, but there we go.
yeah. Sorry.
There we go.
It's still in AWS.
Yeah.
So we have a load balancer in front here. So all the requests will be coming into the load balancer, and then this entire environment will be running on Kubernetes, and each of this will be a container. So I will also talk about how do we provision an EKS cluster, and I will walk you through deploying this piece of code or these 3 services here. So for some context, this is running on Node. This is running on Python. These 2 are actually running on Python. This microservice, they're both running on Python. I actually wanted to run one of them on Golang, but I was a little bit more comfortable with Python, so that's why I used it. I'm sure some of the folks watching would be like, how dare you use Python for a backend service? But anyway, here we are. So with that said, this is the, so let me get started. So this is the AWS console, as most of you would know. And we obviously can have multiple services here, but let me first start by going to EKS, which is our Elastic Kubernetes service. And I have already prepared a bunch of clusters because you never know when the demo gods would be unhappy. So I've already done some clusters before, but I will take you through the cluster creation process as well. So the first thing you need to do is to click on where it says Add Cluster and then Create. You might notice that the Create Cluster button had a register option there. I will come back to it in a bit, but let me just go through this. So here, as I said, we are a couple of versions behind. And even though you are able to create clusters with the very latest version of Kubernetes, it is recommended to use what AWS says is the default. So, right.
And
so
that also means that when we decide to allow for a new version, or basically have a new version available, customers can then themselves do that upgrade when it fits them.
Yes, and the upgrade process is very seamless. We try and make it as painless as possible. So when you want to do an update, it is simply a matter of updating that cluster. There will be a button that shows up that there is an upgrade available for this cluster, and you can update it. So pretty straightforward to update it. So you don't need to manually update your cluster in that sense, right? So give the cluster a name, select the version, then we need to choose an IAM role for the control plane to access AWS resources. Now, this is very important because when we provision a cluster in EKS, AWS provisions the control plane only initially for you. Then we need to provision what is called the node group, or essentially the worker nodes that are placed in a group separately. So when you create an EKS cluster, the two don't go, the two are not created together when you do it in the console. Now, there is another method that I will show you after I do this that actually does both of them at the same time. So we choose the role, and then if you want, you can use KMS for storing your Kubernetes secrets. So Kubernetes secrets are a resource type within Kubernetes that allows you to store in a sort of like an encrypted fashion things like access credentials, passwords, any other configuration items that your container would need in a secure location within the Kubernetes cluster. So for some customers, they are already heavily invested in KMS. So KMS is our key management service where you can store and manage keys. So this is an option to encrypt Kubernetes secrets with KMS. Sorry for the slightly longer explanation, but completeness, I guess. Then we move, absolutely. So then we we attach the networking to the cluster. So clusters can be VPC native, which means that you can access the cluster's control plane or the API directly from within your VPC. So what that means for customers who want traffic to stay within their VPC is that you don't need the cluster to sit on the public internet for you to access and to run containers. You can isolate all the traffic within your VPC, and you can communicate with the cluster in a secure way. But in this case, I'm not going to do that. I'm just going to show you how a normal cluster would be. Then we need to choose the specific subnets for the control plane as well. And these are subnets in a variety of different availability zones in this particular region that I'm using. So I'm using US East 1. I did not use EU North 1. Yeah, I just didn't. Maybe the next time I will choose Stockholm instead. It's pretty close to you, isn't it, Gunnar? Right. So then security groups are also pretty important. Again, I'm just going to use the default security group. Please don't do what I'm doing for a production environment because it's obviously not the right way to do it. I'm a little loose on security for this demonstration, but bear in mind that security is very important, and especially when you're on production. So yeah, anyway, this is what I was referring to, cluster endpoint access. So we can either have a completely public endpoint, or we can have a public and private endpoint. So as it says here, the clusters endpoint can be accessed from outside the VPC, but traffic from in between the worker nodes to the control plane, to the API server will still be within the VPC. So this is what I'm going to choose. And then we've got some networking add-ons, which are also pretty important for Kubernetes to function. This is pretty cool. And this is an AWS specific implementation because, and you will see this in a bit, when we create containers within EKS, each pod, each container will get its own VPC native IP address. What that means is that the pod on its own would be able to access resources from across the VPC. So let's say if you've got a Lambda function that's sitting in the VPC, the pod can directly access the Lambda function. If you've got RDS, you can access it. Basically anything that sits inside the VPC, the pod can access it. And speaking of pods, the pod is sort of like the fundamental building block of a resource in Kubernetes. So it's basically the resource which Kubernetes uses to run a container. So a container sits inside a pod. You can have hundreds of pods, thousands of pods, whatever. And you can even have multiple containers within a pod. But the important thing to understand is that everything starts with a pod, if you will. Yep. And again, more for DNS, also very important if you want to communicate with different services within your cluster. You don't use the IPs within Kubernetes itself. You would use DNS, which makes it really easy because once you start scaling, let's say you've got like 100 containers of one service, surely you can't send traffic to each individual IP because the IPs tend to be ephemeral because the containers are ephemeral. They get killed and recreated as and when it's needed. So we have to have a more consistent mechanism of communications to the pods, which is why we have DNS. And also kube proxy. And I realize we are not doing so well on time, so I will piece this up. So logging, I tend to enable all the logs because I like to see what's happening. But if you have concerns on how much logs are being generated, then you don't want to do that. So that's it. The cluster creation process does take a bit of time. So I don't want to wait until this finishes. So this is one way of creating a cluster. And if you notice here, there are no nodes. And it also says this cluster does not have any node groups. Okay, so let me come back to the other method that I showed you of how we can create a cluster. Oops.
So ClickOps is not the way that most people create clusters?
No, no. Well, it shouldn't be. It shouldn't be. You definitely need a better way of creating a cluster. So we have this utility called EKS-CTL, which, as it should already be apparent, is a command line utility to manage EKS. And EKS makes it super simple for you to simply create the cluster. And I have the utility installed already. So Office Hours, yes, demo. And that's all I need to do. And what it will do, right, is it will create a manifest, a YAML manifest with all of the resources that it's going to create. So if I do a dry run on this one, what it will actually do is it will dump out the full, it will dump out the full configuration that it's using to create the cluster. So you can see here that it's going to create a cluster in, worker nodes in C and D, and it's also going to use the managed node groups. So I'm not going to go into too much detail on the node groups themselves. Suffice to say that we probably need to be using managed node groups because it makes it easier for Kubernetes to automatically scale up and down. Right, so it's using Amazon Linux, and it's also only got 2 nodes in this cluster with M5 large instance type. So the benefit of doing something like this is that you can modify this without actually having to know what the syntax is for the YAML. Right. So you use the command line utility itself to generate the YAML, modify it, and then submit it again for the creation process. But again, in the interest of time, I don't want to do that. I'll simply do this, and it will throw out a whole bunch of stuff telling you what it's going to do. So it's interesting to note that in the backend, what EKS CTL actually does is it creates a CloudFormation template and basically submits it to CloudFormation for you to create the cluster.
And besides those 2 ways, ClickOps through the console or using EKS CTL, you could, of course, use CloudFormation straight away, or you could use CDK, which is a common approach as well.
Yeah, it is. I don't have the time to talk to do CDK, but it is fairly straightforward to actually create something with CDK. As some of us might have already used it before, all you need to do is just write a small function defining what the options for the cluster are, like the cluster name, number of nodes in the node group, and so on. And again, CDK deploy will give you a cluster. But ultimately, it is all going back as an API call to CloudFormation. I mean, whether you're using CDK or whether you're using EKS CTL, it is still CloudFormation, except with the console, right, ClickOps, which is directly to the AWS API. Okay, so maybe what I will do is not do that. I have some code that I have prepared. So let me just pull.
So now you're setting up the cluster in the background. And as you said, you already had one pre-prepared as well, if needed. But then, should we move over to the application and actually look at what that looks like?
So the code that I have is in GitHub. I think if it's possible, maybe we can share that later. So let me just bring that up. And it's essentially a way to a front end that's based on Node. And I also have, as I said, that's my face there. As I said, the 2 backend APIs also. So what I'll do is I will go through the process of pulling the code from GitHub, building a Docker container, pushing the Docker container into AWS, and also deploying the service as well. Right, so let's start with this API, and I'm going to clone it. So let's go back here. And if we look at the code here, it is fairly straightforward. It's a simple Flask API. and I am also communicating with the RDS instance that I have already created in AWS. So here's something interesting for eagle-eyed viewers, which you might realize that I don't have a credential here. And obviously that is incredibly poor practice to have all of your credentials in code, and worse still, code that's publicly available, because that's how security vulnerabilities and security incidents happen if you have a password on GitHub, right? So what I'm actually doing is I'm using service accounts to communicate directly with RDS. So I'm actually generating a token by using Boto3. So what Boto3 will do is it will use the service account that Kubernetes has, maps it to an AWS IAM role, and uses that role to access RDS. Okay, so which is pretty cool. Right, so pretty straightforward here, Python code. Now I want to highlight something called a Docker file. So a Docker file is the definition of how a Docker container needs to be created. So a Docker file has some key components, which essentially looks a bit like this. It's sort of like an instruction set for Docker to build a container, to package and image a container. And most Docker files always need to start from a base container. So in this case, I'm using something called Alpine. You can use any publicly available container. So you can use Ubuntu, you can use Debian, you can use, what have you. And once we have the base container, then we need to tell Docker, hey, look, I need you to add these additional packages so that I can run my code, which is why I'm doing this APK add. So if you're using Ubuntu, you might use apt or something else that you might need. Alpine is a very low footprint container. If you remember at the very beginning of our session, I talked about how difficult it takes time for VMs or EC2 instances to start up. Containers take a very short amount of time to start up, but they also tend to take more time if they are bigger. Alpine is tiny. This entire image is about 130 MB, which makes it really fast for the container engine Kubernetes to pull it and to run it as well. So you can scale in like microseconds. Anyway, you do the package addition, installation of the packages, then you create a work directory, you copy the code, these files here into an application directory that you create, that you've just created. Then you run your pip install, you expose the port 80 for Docker to route traffic into the container, and then you start the application code by doing your Python 3 app.py. This entry point needs to be in a Docker file because it is good practice. You can do another command as well, but entry point makes more sense because it's how the container starts, essentially. Okay, so with that said, maybe let me build the container. So it's just a straightforward process of running this command. So I'm doing a Docker build and I'm tagging my container with this tag, with this name and tag. And I'm saying, look for the Docker file in the current directory. So as you can see, it's actually loading, it's pulling a base image from the publicly available Alpine image. And then it is doing the installation and a bunch of other stuff. So some of you also might see this here where it says exporting layers. So layers are a concept of Docker that allows each particular section to be stored as an individual component. So when you reuse the same component, Docker doesn't need to pull it again from scratch. It will simply use the cached component and build a container image based on these layers. So it actually makes running an image much faster. Okay. Then I need to do something called Docker tag. And this is where we need to go back into AWS, because I want to put this Docker image into something that I call something that we call a container registry. So a container registry is sort of like a location where we can store containers. And you might notice that I don't have something created for my Coffee API, which I'm going to do. So I want to create a Coffee API repository first. And it's, again, pretty simple to do that. And once I have the Coffee API created, I can then go back here. And I need to tell Docker, hey, look, you need to push your container images into ECR. And how I do that is by logging in to ECR by doing this command. So AWS ECR, AWS is our AWS command line tool. ECR, get login password for this particular region, and then I'm typing it into the Docker login command. So Docker login automatically logs into your personal private registry, and you can have it either on a cloud platform like on AWS, or you can have it on your own private repository on-prem, or even Kubernetes itself. There's a container registry called Harbor, which is part of the CNCF, and you can store your containers in Harbor as well. So once I do this, it logs into the container registry, and now I need to do something called Docker tag, which essentially prepares the container to be pushed into, to be pushed into this container registry. And then I can do a Docker push to this one. Okay. Oh, sorry, wrong. Sorry. Yeah. You should have tagged.
There we go.
This. Yeah, but anyway, yeah, it's fine.
So, right, so now you're
once
pushing that container to the registry.
Yeah. So once the push is done, then we should be able to see it here. ECR also has this ability to automatically scan your containers for any vulnerabilities, which is very useful, especially when you are running containers in production. So, and with a combination of fully automated build and deploy processes, ECR becomes a very useful tool in your security posture, because when you submit your code, a pipeline is triggered that builds the container and then pushes it into ECR. ECR scans it before you deploy it. So this is sort of like a step in your DevSecOps process, if that makes sense. Yeah, I think it should be done. It's not.
We've seen a couple of times that you've added a version to your container, and that means that you're able to have multiple different versions in the repository, and then you can deploy them to, say, a production cluster or to a test cluster or whatever it might be. So you're able to test your new versions before pushing them into a production environment.
Yep, absolutely. That's a good call out. Thanks, Gunnar. So the tags can be anything that you want. They don't necessarily need to be version numbers, but the containers themselves are versioned in ECR. So you would be able to see when you pushed these containers. So for example, you can have multiple instances, multiple versions of the container tagged with, let's say, dev or prod, or let's say a particular feature. Let's say, I don't know, some piece of code that you did not want to include that's there, but you also have another container that includes this feature. So you can use that same container repository, but with two different versions of the container for, let's say, A/B testing. So in your production cluster, as you said, you can deploy one version of the container, and then in your dev cluster, you can deploy another version of the same container.
Right. So if you just join us, this is the AWS Nordics Office Hours. I'm Gunnar. I'm joined by Thiru today, and we're talking about getting started with Kubernetes on AWS. And Thiru has created a cluster for us. He's downloaded some code from GitHub, not random code, it's his repository. He's built a container and is now pushing it to the container registry in his AWS account.
Yep. And unfortunately, it is taking a bit of time, I think, because of my internet connection. Completely empty room, so I don't have more Wi-Fi capability, unfortunately. Cool. So it's done, thankfully. And if we refresh, we should now be able to see the container. As I said, it's about 130 megs. So if you open up the details about that image, you can see that there is something called a URI, which is very important for us in the next step. So, and then in the interest of time, perhaps I will skip through a few things and just get to the meat of it. So we have Kubernetes manifests. So Kubernetes manifests are a way for you to tell Kubernetes what you want. So manifests are something that are what is called declarative instructions. So a declarative instruction is something where you tell a service what you want and the service does it for you, rather than you specifying what to do to the service directly. So Kubernetes makes it very easy for you to create a declarative approach to your container deployment, which makes it also very easy for you to do configurations, for you to change configurations, and for you to perform scaling and to do a wide number of activities, right? Which is something that sets Kubernetes apart, in my opinion. So I actually wanted to take you through how to create this manifest from scratch, but I think I spoke a little too long. So I will just show you how the manifest looks like and how we're going to deploy it. So all Kubernetes manifests always start with this API version line here, which actually tells the Kubernetes API server what API we are referring to. And you might have heard me talk a lot about Kubernetes APIs because at the base of it all, Kubernetes is just a very complex REST API that interacts with infrastructure. When you submit a manifest like this, you are essentially communicating with the API using this manifest. You can directly communicate with the API if you want. You can write some code to talk to the API directly, which is what a lot of applications do. But for us, it is very easy to use a manifest like this to tell Kubernetes what to do. So what we are saying is we want something called a deployment. A deployment is sort of like a resource object that packages pods together in a collection. And we are able to make that collection larger or smaller. So we are calling that collection Coffee API. And I have already created a service account within Kubernetes itself. Let me do that command, which almost everyone is familiar with now. kubectl. And kubectl is your way of interacting with the API server. So this is I'm not working with the cluster that we just created, because I don't think the cluster is done. Okay, maybe it is. But anyway, I'm not going to use that cluster. I'm going to use this one, Office Hours Demo 2, which I actually created a little earlier. So Office Hours Demo 2 already has a node group provisioned, and it is essentially good to go. So I'm going to use this cluster. And what I'm going to do is I'm going to prepare kubectl to talk to that cluster by using this command, AWS EKS update kubeconfig. Kubeconfig is the configuration file that tells kubectl what to do. And I'm going to specify the name of the cluster along with the region. And once I do that, it already has updated my config file. And now when I do kubectl, let's say get nodes, I should be able to see my nodes as well. And let me see if I can create my so this is important here. Right. So I've already created the IAM role that that we need to use for Kubernetes to talk to the AWS API. So if I go back here, I just want to very quickly show you the role itself. And this allows me to talk to RDS, and it also allows me to talk to DynamoDB directly. So what I'm going to do next is I'm going to tell this Kubernetes cluster to create a Kubernetes service account and map that Kubernetes service account into AWS IAM. I'm not sure if this will work here. Okay, so and I'm using EKSCTL to do it. So
it's not not something we want to hear.
No. Let me see that.
Especially with 5 minutes to go.
I know, but okay.
Right.
Since I expected this, so what I will do is I will actually end up using my my first Kubernetes cluster that I created yesterday, which is thankfully still there, which I've not deleted, which is this one. And let me do this instead. Okay, so this works a lot better because I had time to deploy it. I've already created the service account, as you can see, and now I want to do my deployment. So what I need to do is to go into the kube folder, like how I've shown you here, and then I want to submit this deployment into Kubernetes. So what I do is kubectl apply, and I point it to the YAML file. So apply is basically telling Kubernetes kubectl, hey, look, implement all of the things in this file. And it's done. And the reason why it says unchanged is because it's already running. But suffice to say that this is the process that you need to do. And the other thing that we need to do is also to create something called a service, which specifies what ports to use. So I've also already deployed the service. And again, in the interest of time, like you said, we only have 5 minutes, so maybe I'll skip through a lot of the stuff. I've already implemented another API, which is called Cake API. It's also running on Python, but it communicates with DynamoDB instead. And we also have the front end, which is called Cafe front end, and it's running in Node. And what it does is it communicates internally with the Coffee API and the Cake API directly. So if you see, I'm not using an IP. I am simply using the DNS name for the service, which I have defined here. This one. So when I do this, when I tell Kubernetes that I want a service called Coffee API, it also automatically registers it with DNS internally. So any pod anywhere in the cluster should be able to access this service as long as it uses this name. So, and the same goes for my Cake API as well. So my Cake API is called Cake API. And I basically call my my two APIs directly from my front end. So this represents a very typical scenario where you have one front end application that is exposed to the internet, and you have two or as many backend applications that you don't want exposed directly to the internet. Okay, so I have deployed all of these into this particular cluster, and as you can see, it's already here. So they are all the same. So they have 3 replicas each, and I've already deployed my Cafe front end service as well. And it is available on a public site, which I will show you. Actually wanted to show this here. 1 second.
1 minute.
Oh no.
Oh yeah.
But anyway, let me just open this directly. So I'll just. So this is basically the demo application. So what it does is it automatically refreshes and it keeps pulling the code it keeps pulling the data from the different services and displays as well which pod it was running on and stuff like that. So you can see that it is automatically refreshing. It is also getting the data from a bunch of different pods in the backend. And this is especially useful when you want to see scaling in progress. So yeah, unfortunately, there were a lot more things that I wanted to just show, like how Kubernetes scales. But yeah, so yeah, this is unfortunately all that we had time for.
You got it working. All right, yeah. So with that, it's time to wrap up. I see we have a couple of questions in the chat that we didn't have a time to get to, but I'll ping you separately after this. And so, Thiru, what we did today was start out with basically what containers was, and then moving over to Kubernetes. You created a cluster in EKS. Then you created an application simply by using the repo that we shared in the chat. You then created container, pushed that to the registry, and you were then able to deploy that into your cluster. Was that a summary?
Pretty much.
Yeah. All right.
Yeah.
So
you did it really well.
So time is up. Thanks everyone for joining. Maybe we need to have Thiru back to go more into depth to certain things, and I'd be happy to have you again, Thiru. Thank you for joining us.
Absolutely. Thank you, Gunnar, for having me. It was good. Thanks. Take care, everyone.